Very good afternoon to one and all. I welcome you all in the next lecture of heat and heat transfer. Whether my voice is audible and can you see my presentation? Please let me know. You can comment in chat box. Great, great. Okay, so you can adjust your screen. Uh, you can rotate your screen and you can use the zoom feature of a screen so that the data on the PPT will be more visible to you. Okay, so in the last lecture, up till now, we have discussed the three modes of heat transfer. That is nothing but conduction, convection, and radiation. Then we have also discussed the laws related to these three particular heat transfer modes. In conduction, we have discussed uh, the Fourier's law of heat conduction, whereas in convection, we have discussed uh, the Newton's law of cooling, and in radiation we have discussed in the last lecture we have discussed the Stefan Boltzmann law. Okay, so that will provide you the general idea about the subject. Okay, and we are going to discuss in detail this particular modes of a heat transfer. In detail, particular mode in detail we are going to discuss. Okay, so uh, up till now whatever we have discussed, that is about the first part of a first chapter. Okay, so 1.1 we have covered. So just in this particular lecture we are going to dive into 1.2, that is the steady state heat transfer. Okay, and the first important point of this particular segment is general heat conduction equation in Cartesian coordinate system. Okay, general heat conduction equation in Cartesian coordinates system. Okay, so the important thing is nothing but we should know that what is meant by Cartesian coordinate system. Okay, so there is a spherical coordinate system, there is a cylindrical coordinate system, and last one is the Cartesian coordinate system. So Cartesian coordinate system is having three coordinates. Okay, most important, it is having the three coordinate, that is nothing but x, y, z. Okay, and by using these three coordinates we can locate any point in the space. Okay, we can locate this particular a point. Here you can see that we have to locate this a point in a space by using the Cartesian coordinate system. So for that reason we required the three axes, that is x, y, z, or the points or the distance from these three particular axes. Okay, so in Cartesian coordinates, there are three axes we are using to locate any point in a space. Okay, to locate any point in a space. So it is also called as a rectangular coordinate system. It is also called as a rectangular coordinate system. Getting everyone? So there are different coordinates used in a spherical coordinate system and in a cylindrical coordinate system. While discussing that particular points, we will understood what is meant by spherical coordinate system and what is meant by cylindrical coordinate system. Okay, here you have to remember that in Cartesian coordinate system we have to use the three coordinates or the distance from the three coordinates to locate the point in a space, or to locate the point on any element, to locate the point on any element. Okay, then now the actual derivation about this Cartesian coordinate system, general heat conduction equation in a Cartesian coordinate system, we are going to understand this equation in this particular lecture. Okay, so for that reason we have to consider one infinitesimally small volume element. Okay, we have to consider one infinitesimally small volume element. Okay, which is having the thickness dx, x direction it is having the thickness of a dx, whereas in y direction it is having the thickness of a dy, and in a z direction it is having a thickness of a dz. Okay, so consider a small volume element with thickness dx, dy, dz in x, y, z direction respectively, in which, okay, now in this particular element the temperature is varying with respect to location and time. Okay, temperature is varying with respect to location and time. Okay, and we need to determine the general heat conduction equation in such a condition. Okay, so element, okay, so this is the element we have considered, infinitesimally small volume element we have considered. Okay, so try to understand this particular diagram. Okay, so we can say that this A point is the origin of all the axes. Consider this A point is the origin of all the axes, and from that particular point we are measuring the distance. Okay, let's say we are measuring the distance. Okay, so A is having the coordinate system of x, y, z. Okay, point A is having the coordinate system of x, y, z. Okay, now we can say that this is the x direction. We can say that this is the x direction, then this is the z direction, this is the z direction, and this is the y direction, this is the y direction. Okay, getting everyone? Now the nomenclature is provided for each corner of a cube. Okay, nomenclature is provided to each corner of a cube. Okay, so this corner is we can say that A, then this corner is B, then this corner is C, this corner is D, this corner is H, this corner is E, this corner is F, and this corner is G. Okay, so draw one cube. Okay, you also start drawing. Draw one cube. Okay, provide the initial nomenclature for each corner of that particular cube. Okay, each corner of particular cube. Now the thickness we have discussed that the thickness of a cube in x, y, z direction is dx, dy, dz. Okay, dx, dy, dz. Okay, so thickness is dx. We will not consider the cube, we will consider the parallelepiped, because cube is having all sides are having same length, or we can say that same thickness, so we can't consider the cube. We will consider it as a parallelepiped. Okay, which is having different thickness in different direction. Okay, so dx, okay, in x direction having the thickness of this particular parallelepiped, infinitesimally small parallelepiped, having a thickness of a dx. Okay, so now in direction of a z, okay, this is the z direction, right? So in direction of a z, it is having a thickness of a dz. Okay, dz, or having a length of a dz. Okay, and in y direction, okay, this is the height. We can say that in y direction it is having a length of a dy. Okay, it is having the length of a dy. Okay, so first initial strata about the diagram is important. First is nothing but nomenclature, and you have to provide the thicknesses or the lengths in a particular direction. Okay, so we have considered this is the x direction. Okay, this is the origin. A point is the origin of all the axes, and this direction is the x direction we have considered. Then this direction is z direction, and vertical direction we have to consider it as a y direction. Okay, we have to consider it as a y direction. Okay, so draw it. Okay, now Next, from all three positive directions, heat is coming inside the element. Okay. So here in x direction, q suffix x amount of heat is entering inside the element. Okay. In positive x direction, q suffix x amount of heat is entering inside the element. Okay. Whereas in a positive y direction, okay, upper direction or moving from bottom side to the top side, that is nothing but positive y direction. Okay. So positive y direction. So in positive y direction, q suffix y amount of heat is entering inside the element. Okay. Q suffix y amount of heat is entering inside the element. Okay. Then in a positive z direction. Okay. So this is the positive z direction. So in positive z direction, okay, positive z direction, qz amount of heat is entering inside the element. Qz amount of heat is entering inside the element by conduction. Okay, we are dealing with the conduction only. So qz amount of heat is entering in a z direction into the element. Okay, so you can give the notification or nomenclature over here by showing the arrow in that particular direction. So this is the positive x direction. Qx amount of heat is entering by conduction in that particular element in that direction. Then qy amount of heat is entering inside the element in positive y direction, and qz amount of heat is entering inside the element in a positive z direction. Okay, positive z direction. Okay. Now, after entering inside the element, there will be some changes in the heat. Some amount of heat will be stored in the element. Okay, or it will be get away from that particular element, or it will be transferred to another element by conduction. Okay, so from positive 3 direction, some amount of heat will be entered. Further, from the opposite side from the opposite face, the heat will be escaped or getting outside from that particular element. So there is some changes. Okay, same amount of heat will not be coming out of the element. Sometime it will be increased or sometime it will be decreased. Okay, so the change in heat will happen when it will entered in the element. Okay, why? Because some amount of heat is absorbed or stored by the element to increase its own temperature. Okay, increasing temperature of an element is because of that particular element stored some amount of heat. Okay, or if that particular element is considered as a heater element. Okay, consider one heater and element of that particular heater, and if you transfer the electric current through that particular heater, at that time each element of a heater will generate the heat. Okay, each element of a heater will generate the heat, or each molecule of a heater will generate the heat. Okay, so in that case also the temperature of a element will goes on increasing. Okay, so that is the case over here. Here we are considering that this particular element is also generating heat. Okay, this particular element is also generating heat. So total amount of heat generated, okay, that is q suffix g, that is heat generated by the element, will be provided as q suffix g multiplied by dx multiplied by dy multiplied by dz. Where is this dx multiplied by dy multiplied by dz is the volume of element. Okay, and q suffix g, small q suffix g, is the heat generated per unit volume per unit time. Okay, heat generated per unit volume per unit time. We will discuss this later on, but remember that this point showing here, what it signifies? It signifies that this particular element is also generating the heat. Okay, so in case of a heater, we know that if you transfer the electric current through the heater, heater will generate the heat. That means what? Each element of a heater will generate the heat. Okay, so one of the element of that particular heater we have considered over here. Okay, let us assume that one of the element of that particular heater we have considered over here, and we are analyzing the heat transfer through that particular element. Okay, so in that case, this element will also generate the heat. This element also generate the heat when it receives the electric current. Okay, when it receives the electric current. So at that point, we can say that Q suffix G is the heat generated in the element. Heat generated in the element. Okay, so now we have discussed that heat is coming inside. Also, this particular element is also generating the heat. Now, from the other faces, okay, from this side, heat is entering in a x direction. From this side, heat is entering in a y direction, and from this side, heat is entering in a z direction. Okay, from opposite faces. Okay, this is the face for entering the heat in a x direction. From the opposite faces, heat is leaving this particular element. Okay, heat is leaving this particular element. So there will be some changes. There will be some changes in the heat, and that change we have to consider it as a Q suffix x plus dx. That change we have to consider it as a Q suffix x plus dx. Okay, so change in heat will be happen when it leaving in a x direction. Okay, opposite face or in the direction of x. Okay, in a similar fashion, as this heat is entering in a z direction from this particular face. Okay, which face? DAEH. Okay, and it is leaving through space through face BFGC. Okay, and there is also arrow we have shown over here, and there is also a change in heat when it leaves from the another side. Okay, so that change in heat is nothing but, or the amount of heat leaving in a z direction from opposite face will be Q suffix z plus dz. Q suffix z plus dz. Okay, that will be considered as there is some change in heat. Some amount of heat will be stored, or some amount of extra heat will be added because of heat generation of element. Okay, okay. So, and in a similar fashion, the heat is leaving in a y direction from the space DCGH space phase. Okay, so on that heat leaving through y direction will be considered as a Q suffix y plus dy. Q suffix y plus dy. Okay, getting everyone? So this is the general explanation of this diagram. Please draw it neat and clean and show all the parameters in the diagram. Okay, all the nomenclatures, all the parameters, and naming for each corner is required. Naming for each corner is required. Okay, if you will not understood, you revise 1 2 time. Okay, then you will try will start understanding this particular diagram and the derivation. Okay, so revision is most important. In first stroke you will not understood anything, but once you revise these points, you will start understanding each and every point. Okay, there are so many concepts involved in this particular derivation. So it is most important to understand the derivation, and revision is also most important. After completion, please comment in the chat box, okay, whether you have completed or not, or shall I move ahead? Draw it neat and clean, and show all the nomenclatures appropriately. Okay, appropriately. So diagram is most important to understand the derivation. Okay, diagram is most important to understand the derivation. If you understand the diagram, it will be easy to understand the derivation. Okay, Okay. So further you can write consider. Have you drawn or more time you required? Please comment in chat box whether you required more time or shall I move ahead. Over. Okay. So now next, write down. Consider a small volume element. Okay. Consider a small volume element with thickness. Consider a small volume element with thickness dx, dy, dz. Consider a small volume element with thickness dx, dy, dz in x x comma y y z direction respectively, in x y z direction respectively, in which in which in which temperature is varying temperature is varying temperature is varying with location and time, with location and time. Okay. Over. Okay. So you have drawn this diagram, and this is the basic diagram to understand the derivation. Now let, okay, let T is equal to temperature at the left face ABCD. Okay. T is equal to temperature at the left face ABCD. Okay. Left face, which is the left face ABCD? A, B, C, and D. Okay, this face. Okay, this face temperature, this side temperature. Okay, on this side temperature, इस side का temperature कितना है? इस side का temperature कितना है? वो कितना है? T degree Celsius है. Okay, we are assuming this particular point. So the A, B, C, D, this face or this side. Okay, this side is maintained at a T degree Celsius temperature. Okay, we are assuming that. Okay, and this temperature may be assumed uniform over the entire surface, since the area of this face can be made arbitrarily small. Okay, we have considered infinitesimally small volume element. Okay, so area available of this particular face is also very small, so that we are considering that the T temperature is uniform. Uniform means what? At every location of this face is having T temperature only. Okay, that is the uniform temperature. If you check the temperature at this point, or at this point, or at this point, or at any location on this face A, B, C, D. Okay, on this face you will get the temperature T only. Okay, so T means in that particular value. Okay, so we are assuming the T temperature, or T is equal to temperature at the left face, and this temperature may be assumed uniform over the entire surface, since the area of this face can be made arbitrarily small. Now further thing, what we are going to assume, that dt divided by dx. Okay, dt divided by dx is equal to temperature change along x direction. Okay, now we have considered that this face is maintained at a T degree Celsius temperature, but heat is flowing from this direction to this direction in x, or we can say that from this face to this face in x direction heat is flowing, right, because we are showing the heat flow symbol. Okay, in this direction, that is q suffix x amount of heat is entering through this particular face inside the cube by conduction, or inside the parallelepiped element by conduction, and it is leaving from other side side face, and so that we can say that the heat flow direction is this. Okay, in x direction, heat flow direction is this one. Okay, so we can say that there is a change in a temperature in x direction. There is a change in temperature in x direction with respect to its length. Okay, whatever the length traveled by the heat, whatever the length traveled by the heat. Okay, so during that length in x direction, the variation in temperature will happen. Variation in temperature will happen, and that variation, we can say that change in temperature with respect to change in length. Okay, that variation, we can say that change in temperature with respect to change in length in x direction, that is nothing but temperature gradient, or we denote it as a dt divided by dx is equal to temperature change along x direction. Temperature change along x direction. Okay, now now, we are considering that now here I have drawn one simple diagram, okay, for the understanding purpose, okay. So, my drawing is not that much good, but I tried to draw it for the understanding purpose, okay. So, let us consider, okay. So, this thickness, okay, in x direction parallelopiped की thickness कितनी है dx है, okay. We are considering it is a dx thickness in a x direction, okay. So that dx thickness we have taken over here, okay. Now consider that we have divided this dx length in a number of parts, okay. Or let us consider this dx length is 10 centimeter, okay. For enlarged view, you consider this dx length is 10 centimeter, okay. And we have divided this dx length in a equal parts. We have divided this dx length in equal parts. Let us say into 1 centimeter, okay. It is divided into 1 centimeter, 1 centimeter, 1 centimeter. Each element or each element of this total length is having 1 centimeter length, okay. So now what will happen? The heat is flowing in x direction, okay. So there is a temperature difference, okay. There is a temperature difference at each element node, okay, at each element node of this particular length, okay. So that temperature difference we considered as a delta T, okay. So further derivative of small element will be considered as a delta T, okay. And further derivative of length is also considered as a delta x, okay, because we are considering the total length in a x direction as a dx, okay. And we have divided that length in a small element. Once again we have divided that particular total length in a small element. So further division or derivation of dx will be considered as a delta x, okay, will be considered as a delta x. And the change in temperature for one single element, small element, will be considered as a delta T, okay. समझते सगळ्यांना? Whether you understood or not? क्या किया है हमने? पहले हमने क्या देखा कि dx लेंथ है, dx थिकनेस है इन x डायरेक्शन में, ओके. वो थिकनेस यहाँ पे ले ली, ओके. टोटल लेंथ कितनी है हमारी? dx है. फर्दर उसमें क्या किया? वो थिकनेस हमने स्मॉल एलिमेंट में डिवाइड कर दी, ओके. और ईच element having thickness of a small or delta x. Each element is having the thickness of a delta x. Now we know that the temperature never constant. Initially we have discussed that it changes with respect to time and a location. So when heat is transforming, and because it is changing, so that only the heat is transferring. Okay, it is changing so that only the heat is transferring. So at this location, the temperature will be different, and at this location temperature will be different, and the difference between these two temperatures we have considered as a delta T. Whether you understood or not? Okay. Now total change in temperature, okay, from the right side to the left side, okay, what we have discussed, delta T, delta x, you understood. Dx is the total length, okay. Delta x is the small elemental length of dx, and delta T is the small elemental temperature change of total length, okay. Small elemental temperature change of total length, okay. Now we know that the ABCD phase, this phase is maintained at a T temperature, okay. Then what will be temperature at EFGH? then what will be the temperature at EFGH? That we have to find out. Okay, so for that purpose, this understanding will be useful to you. This understanding will be useful to you. Okay, so temperature on the right face EFGH at a distance dx will be, okay, what it will be. Initially, the ABCD phase is maintained at a T temperature, okay, and temperature is changing for a small element, okay. Temperature GABA T temperature is changing with respect to small elemental length, okay. GABA T temperature changes with respect to small elemental length GABA X, okay, okay. हर एलिमेंट में डाबा टी टेम्परेचर चेंज हो रहा है, हर एलिमेंट में डाबा टी टेम्परेचर चेंज हो रहा है, हर एलिमेंट में डाबा टी टेम्परेचर चेंज हो रहा है. तो टोटल लेंथ में कितना टेम्परेचर चेंज होगा? लेट अस से हर एक सेंटीमीटर के बाद 1 डिग्री सेल्सियस टेम्परेचर चेंज हो रहा है, हर एक सेंटीमीटर के बाद 1 डिग्री सेल्सियस टेम्परेचर चेंज हो रहा है, हर एक सेंटीमीटर के बाद एक डिग्री सेल्सियस टेम्परेचर चेंज हो रहा है. तो 10 सेंटीमीटर डिस्टेंस ट्रैवल करने के बाद कितना टेम्परेचर चेंज हो जाएगा? 10 सेंटीमीटर डिस्टेंस ट्रैवल होने के बाद कितना टेम्परेचर चेंज हो जाएगा? ऑब्वियसली 1 multiply by 10. 1 degree Celsius per 1 centimeter it is changing, okay. 1 degree Celsius per 1 centimeter it is changing. So 10 centimeter के लिए कितना चेंज हो जाएगा? 1 multiply by 10 or 1 by 1, 1 degree Celsius per 1 centimeter multiply by 10 centimeter. That will be the total change in the temperature when it travel from traveled by the dx distance or a 10 centimeter distance. For the understanding purpose, I am taking the 10 centimeter distance. Okay. So the similar thing we have noted in a equation format. Similar thing we have noted here for in a equation format, that initial ABCD phase is maintained at a T degree Celsius temperature. Now heat is traveled from this phase to this phase, okay. So heat traveled dx distance, and during that dx distance, how much change will happen in a temperature, that we have to interpret in a equation format. So this equation format will be what? The initial phase is maintained at ABCD phase is maintained at T degree Celsius. Incremental change in a temperature with respect to small elemental length is DABA T divided by DABA X, and total it should be multiplied by total length. Okay. So temperature example लिया हमने, क्या लिया कि 1 सेंटीमीटर डिस्टेंस ट्रैवल किया हीट ने, तब 1 डिग्री सेल्सियस टेम्परेचर में फर्क मिला हमें. ओके. तो 10 सेंटीमीटर ट्रैवल करने के बाद कितना फर्क मिलेगा हमें टेम्परेचर में? तो 10 डिग्री सेल्सियस. ओके. सिंपल. इन ए सिमिलर फैशन ये वही रिप्रेजेंट करता है. ये 1 डिग्री सेल्सियस टेम्परेचर चेंज हुआ 1 सेंटीमीटर डिस्टेंस ट्रैवल करने के बाद. तो ये 10 सेंटीमीटर मल्टीप्लाई किया तो कितना टेम्परेचर चेंज होगा? 10 डिग्री सेल्सियस टेम्परेचर चेंज हुआ. ओके. सो ये चेंज किसमें हो रहा है? ये चेंज किसमें हो रहा है? तो इनिशियल टेम्परेचर में हो रहा है. कौन सा टेम्परेचर है वो? एबीसीडी फेस का टेम्परेचर है. कितना है? एबीसीडी फेस का टेम्परेचर T डिग्री सेल्सियस है, और वहां से हीट ट्रैवल करके EFGH फेस तक पहुंची, और उसमें क्या हुआ? टेम्परेचर में चेंज हुआ. वो ट्रैवल करते वक्त टेम्परेचर में चेंज हुआ. कितना हुआ? वो चेंज कितना हुआ? डाबा T डिवाइडेड बाय डाबा X मल्टीप्लाई बाय dx इतना हुआ. Okay. So we have to add this change in an initial temperature. Okay. We have to add this change in an initial temperature so that we will get the final temperature at EFGH. Okay. So DABA T divided by DABA X multiplied by dx is equal to change of a temperature through distance dx. Okay. Through distance dx. DABA T divided by DABA X multiplied by dx is equal to change of a temperature through distance dx. Okay. Up till now, any question, any doubt? Please mention in the comment box whether you understood or not. Shall I repeat? I don't want to do hurry to teach this particular point. I want that everyone should understand. Okay, if you understood this particular point, it will be easy to understood the subject completely. Okay, so point is more important. Okay, so this derivation, there are 14 kinds of derivation in first chapter only. Okay, and this is just a example one. This is the example type of derivation. So if you have any doubt, any question, you can comment in the chat box, or you can unmute and you can ask that question. Okay, or else if you understood everything, okay, then just put understood. Okay, repeat the temperature change part. Okay, so from start I will from beginning I will start this particular point. Okay, first we have discussed that point A, the face. Okay, face means what? The side of this particular parallel pipe. There are total number of how many sides? Okay, 1, 2, 3, 4, 5, 6. There are 6 sides for this particular parallel pipe. Okay, so this side, which side? Side A, B, C, D. Okay, this side is maintained at a T degree Celsius temperature, and this temperature is uniform over the all surface. Okay, this temperature is uniform over all surface. Which surface? A, B, C, D surface. Okay, this understood? Okay, now the heat is traveling in a x direction. Heat is traveling. Initially, we are removing out y, z direction. Only focus on x direction. Okay, heat is traveling from this phase to this phase. Okay, heat is traveling from ABCD phase to EFGH phase. Okay, heat is traveling from ABCD phase to EFGH phase. Okay, so it will be travel in a unidirection. Okay, it will be travel in a unidirection, and to reach that particular heat to EFGH phase, it should travel distance of dx. It should travel distance of a dx. Okay, इस फेस का और इस फेस में कितना डिस्टेंस है dx इतना. Okay, so to reach the heat to another surface, it should travel the distance of a dx. It should travel the distance of a dx. Now when it traveling from this phase to this phase, there will be some temperature change. Okay, there will be some temperature difference in between this phase temperature and this phase temperature. So that total temperature change with respect to length traveled by heat will be considered as a dt divided by dx, which will be considered as a temperature change along x direction. Okay, no doubt up till now. Then further, what we have done, we have to understood the internal temperature changes also. Okay, so for that purpose we have considered the dx length. Okay, in x direction, this is the dx length. Further, we have divided this dx length in a small element. Okay, further we have divided this dx length in a small element. Okay, so for the understanding purpose, let us consider the dx length is 10 centimeter, and we have divided this 10 centimeter in a 10 parts. Okay, so each element of this dx length is having 1 centimeter distance. Okay, each element of this dx length, or that each element is of dx length is having 1 centimeter distance. Okay, for each element, temperature changing 1 degree Celsius. Okay, further change in temperature will be considered as a delta T. Okay, because we are dealing with very small element. Okay, so for that purpose we have to use the operator delta. So delta T is the temperature change in a small element. Okay, इस लेंथ में टेम्परेचर चेंज कितना देखा हमने? dt देखा. ओके, टोटल टेम्परेचर कितना देखा? dt देखा. अब उसके स्मॉल एलिमेंट में टेम्परेचर चेंज कितना है? delta T इतना है. ओके, छोटे एलिमेंट में 1 सेंटीमीटर लेंथ में कितना टेम्परेचर चेंज होता है? delta T इतना. लेट अस कंसीडर 1 डिग्री सेल्सियस टेम्परेचर चेंज होता है. सेम टेम्परेचर चेंज अगले अगले एलिमेंट में हो जाता है. ओके, अगले एलिमेंट में उतना ही टेम्परेचर चेंज हो जाता है. इन अ सिमिलर फैशन द सेम टेम्परेचर डिफरेंस we can see in a further elements. Okay, further elements. Okay, so यहाँ पे हमने जो डाबा एक्स एलिमेंट जो देखा है उसमें उसकी लेंथ कितनी है 1 सेंटीमीटर. सो वी कैन एनालाइज दैट फॉर ईच 1 सेंटीमीटर देर इज अ चेंज ऑफ 1 डिग्री सेल्सियस. देर इज अ चेंज ऑफ 1 डिग्री सेल्सियस. सो तुम्हारा डाबा टी डिवाइडेड बाय डाबा एक्स कितना हुआ 1 डिग्री सेल्सियस बाय 1 सेंटीमीटर हुआ. अब हमारी टोटल लेंथ कितनी है, टोटल लेंथ है dx. सो वी हैव टू फाइंड आउट द टोटल चेंज इन टेम्परेचर. ओके, वी हैव टू फाइंड आउट द टोटल चेंज इन टेम्परेचर. सो हमें इस डाबा टी डिवाइडेड बाय डाबा एक्स को किससे मल्टीप्लाई करना पड़ेगा, टोटल लेंथ से मल्टीप्लाई करना पड़ेगा. तो हमें पता चलेगा कि कितना टेम्परेचर चेंज हो गया है. तो हमें पता चलेगा कि इस टोटल लेंथ में कितना टेम्परेचर चेंज हो गया है. सो डाबा टी डिवाइडेड बाय डाबा एक्स मल्टीप्लाई बाय dx, that is the total length of length available for the heat flow in a x direction. So dabba t divided by dabba x multiply by dx, you will get the change in temperature in x direction. You will get the change in temperature in x direction. Okay, so ये change किसमें हुआ है, ये change किसमें हुआ है, इनिशियल टेम्परेचर में हुआ है, इनिशियल टेम्परेचर में हुआ है. सो एबीसीडी का टेम्परेचर कितना मेंटेन किया है हमने, टी डिग्री सेल्सियस मेंटेन किया है, और उस टी डिग्री सेल्सियस में चेंज हुआ है. वो कितना हुआ है चेंज, ईच एलिमेंट डाबा एक्स एलिमेंट के लिए डाबा टी चेंज हुआ है. तो टोटल लेंथ के लिए कितना चेंज हुआ है, dx मल्टीप्लाई बाय डाबा टी डिवाइडेड बाय डाबा एक्स. टोटल चेंज इतना हुआ है, और ये चेंज किसमें हुआ है, इनिशियल टेम्परेचर में हुआ है. सो what will be the temperature at the EFGH phase, okay, which will be situated at a dx distance from the ABCD phase. Okay, which will be situated at a dx distance from ABCD phase. The phase EFGH is situated at dx distance from ABCD phase. Okay, so that temperature change is temperature on the right face of a EFGH will be t plus dabba t divided by dabba x multiplied by dx, and the change of a temperature through distance dx will be dabba t divided by dabba x multiplied by dx. Dabba t divided by dabba x multiplied by dx, that will be the change of temperature through distance dx. Getting everyone now up? Any doubt, any question? Okay, okay, great. Okay, so further, please note down up whatever we have discussed. Please note down the points. Let t is equal to temperature at the face. Let t is equal to temperature at the face, at the left face ABCD. Let t is equal to temperature at the left face ABCD let t is equal to temperature at the left face ABCD this temperature may be assumed, this temperature may be assumed uniform. This temperature may be assumed uniform over the entire surface, comma, since the area of this face can be made arbitrarily small, arbitrarily small, full stop. Arbitrarily small means very infinitesimally small. Okay, actually we are considering the volume element is infinitesimally small, so then you can assume that how much small that particular area will be available on left side for surface for ABCD surface. Okay, so arbitrarily small, full stop. Then next, dt divided by dx, dt divided by dx, dt divided by dx is equal to temperature changes, is equal to temperature changes along along x direction, along x direction, temperature changes along x direction. Okay, full stop. Okay, for the understanding purpose you can draw one one small, show the length of this particular, total length of this particular line is dx, and we have divided further it in a small elements, and whose small element length is da by x, and the temperature change in between that particular element is da by t, small temperature change. Okay, smaller than dt. Okay, so small temperature change is nothing but da by t, and that temperature change. Okay, so simple diagram you can show here. Then next, then t plus in bracket, t plus in bracket da by t divided by da by x, t plus in bracket da by t divided by da by x multiply by dx, multiply by dx equal to equal to equal to temperature change, temperature on the right face, temperature on the right face, temperature on the right face, that is EFGH, temperature on the right face, right face EFGH in bracket at distance dx, at distance dx, at distance dx, whereas da by t divided by da by x multiplied by dx, da by t divided by da by x multiplied by dx is equal to change of temperature, change of temperature, change of temperature through distance dx, through distance dx. Okay, so further things, derivation is too long and more concentration is required to understand this derivation. Okay, so we'll stop here. If you have any doubt, any question, you can ask. Okay, and try to understand the figure, that is this particular diagram, and uh, try to match up the situation. Okay, so that's it from my side. Please comment in the chat box your roll number. Please comment your roll number in the chat box. If you have any doubt, any question, you can ask. Okay, so important thing is this particular diagram. Okay, if you understood the diagram, then it will be easy to solve the derivation or move ahead in the derivation. Okay, okay, you can leave.